Hello, AWS fans, Kubernetes, and security enthusiasts. My name's Steve Giguere. This is the AWS Community Summit. Yay! And my talk is going to be called Layer Cake, which I realize I didn't give much of a description, but you'll get the idea pretty soon. Look at those delicious ingredients. What I'm going to be discussing is how we can move security to be more deterministic over being probabilistic. And that probably also needs a little bit more clarity. I did sort of introduce myself already, but let's do a little bit more formally. You can see me down here in the corner now. My name is Steve Giguere. There's my Twitter. There's my LinkedIn because I don't know, masochistic or something. There's a QR code you can use to find me and be friends. I like to meet new people, so let's do it. I have a podcast as well called the Continuous Security Podcast. It's pretty new, so finding it via search can still be challenging, but it's on all good sources, and you can go direct to the website CozyCast to listen direct. I host a meetup online, of course, at the moment called Kubernetes Security or Kubernetes Native Security. You can watch it on Twitch. It's once a month. I think it's the second Wednesday or Thursday. I really should know that. And if you like beer as much as I do, you might want to be friends on Untapped, and maybe watch my YouTube channel called Beer Native. Yeah, I get around. I think I do anyway. Okay, layer cake. Kubernetes for security essentially is what I'm getting into, right? And this wouldn't be a Kubernetes related talk unless I had some kind of nautical photo or Docker, this thing, or like a word cloud. That was a pretty good word cloud. As you can see, I appropriated that from Storage OS, but it's got all the right things in it. And I'm going to start talking about change, specifically change to do with security. For better or for worse, security in this space seems to have fallen onto the shoulders of the INFOSEC teams. Now, if you're familiar with the security people you have to deal with day in, day out, there's like AppSec teams and then there's INFOSEC teams. And rarely do the two connect. Security, this is a whole other talk, but security hasn't quite caught on to DevOps and connecting each other together. They're still relatively siloed around AppSec for devs and INFOSEC for ops, unfortunately. But the paradigms that they're used to experiencing is noise versus danger. So when I mean noise, I think like you've got information coming into your logs in abundance, and you're looking for a needle in a haystack to determine what is right and what is wrong. But they prefer that most of the time over a lack of noise, because then they start to wonder what they're missing. So quiet can be perceived as danger, but that's not necessarily the case anymore. Primitive versus expensive. I'm more thinking like DIY. Are you doing it yourself? And then you're wondering, am I good at what I'm doing? Is this enough? Or buying a great big platform for security and wondering, am I getting my money's worth? Did I just buy a big bloated monster and really I'm only using 10%? This is a struggle. Am I being reactive? Or am I doing everything I can do to be proactive so that I can be as least reactive as possible? That would be great, right? Nobody I watched the TV show called The Umbrella Academy. I don't know if you've seen it. It's pretty cool. And this weird kid character said bluntly, there's no such thing as a pleasant surprise. That too true. So when we're talking about probability versus certainty, certainty feels good, doesn't it? Probability means you're using the equation. Risk equals likelihood times impact. If we can do anything proactive, if we can learn how to be more proactive so that we can reduce either likelihood or impact, or ideally both, we're off to a flying start. Okay. Everything as code is where we want to start, certainly not where we want to end. And we are already doing this. All right, hit me with a high five, Neo. But it's not quite nailed yet. We're almost there. We're introducing the idea of it at the moment. And with that comes great power, but also great responsibility. There are standards out there. There are many standards. CloudFormation, of course, is one I'm sure many people are familiar with. Terraform is another. There's abstraction layers now for generating everything as code, like CDKs and Pulumi, and then there's Cloudify and Cluster API and JSON, good old JSON, Ansible. There are many versions for this. Think of these as like the languages that we use to write our application code. This is the new language of ops. But why code? Why everything is code? Well, back in the day, we used to do everything imperatively. We would create data centers, we would install patches. It wasn't something that often lent itself to repeatable results. There was no change control, mistakes would be made, and many other reasons like, well, humans, there was tribal knowledge there, and where tribal knowledge exists, humans do stupid things. We are our own biggest problem. And sometimes we don't even make good decisions generally. So we need to do, and I was given some kind of funny criticism about this slide because they said, as soon as you say change the battlefield, which is quoting Sun Tzu from The Art of War, then you're a cliche. Well, I'm a cliche. I'm gonna own this one because I kind of feel that it's not terrible. There's a time and a place for every cliche. If we can reduce the likelihood, that equation I was talking about, employee checks earlier and often and scan all that new code for misconfigurations or even security violations, that's awesome. We can also employ new methods to reduce impact, leveraging chaos engineering, using the cattle versus pets, cattle being the new ephemeral objects of our cloud native world, and pets being the cuddly servers that we tried to keep up and running as long as possible. And I realize that is a kind of non-vegan analogy. We need a better one, but it still applies. If we can do that, then we can reduce impact in quite a straightforward way. Combining all that together, well, we can maybe hopefully enter this harmonious world of using the infrastructure as code as context to our advantage when determining risk. And that's kind of what I want to leverage in this talk. The importance of context. All right, true story. The other day, I think it was about a month ago. No, it was in dry January. That's important to know. Important for later. One of my colleagues was on our morning stand-up, and he said, "Ooh, I feel a bit rough today." I'm like, "All right, well, what happened?" He said, "Well, last night I had this beer, and yeah, it was a bit something." And I went, "All right, well, tell me more about it. I'm a big beer fan, like I love to hear about new beer." And he said, "Here, it was this one, and this is actually the beer. It was a BBNO, which is brew by numbers, but that's irrelevant unless you like beer. It's a 64, which is the number for Imperial Stout. But if you know Imperials, this is a Bimber, and it's easier to say if we just do this. Look at the details. It's a 10% Imperial Stout. Now, if I were to draw a parallel in the containerization world, I might say that this is like a container with a CVSS score vulnerability of 10. Might matter, might not. Let's not get all wound up about it just yet. Let's make sure that we go and look at the context within which this is being deployed and using that infrastructure as code to our advantage. And we can do that by looking at the YAML associated with it. Let's bring that in, and there we go, eveningdrinks.yaml. Let's take a quick look at this. It's the Bimber BA Imperial Stout Salad Replicas 3. Oh, we left that detail out. 3 of these. The service was Amazon Prime. The TV show American Gods, why is that relevant? Well, maybe other than the fact that it's quite surreal, but it's only 45 minutes long. 3 of these 10% in 45 minutes is like drinking a liter of wine in 45 minutes. And yes, it was dry January. So I would go ahead and suggest that the context within which this container was deployed was dangerous. Let's try and take this forward into our discussions of our layers. Now, it wouldn't be a talk unless I said GitOps. There, I've said it. GitOps, 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 and then I turn into some kind of a wizard of infrastructure as code deployment, making code great again. Weaveworks described GitOps as opinionated in best practices and prescriptive best practices, I should say. That's what it says on their site. I actually like the fact that they seem to have screen captured Vitor Silva's tweet from, wow, almost 3 years ago now. GitOps in one slide. Git as the single source of truth. Git as the single place where change happens, observable and verifiable. We are really hot on this word GitOps at the moment. And I kind of don't know why. Maybe coming from a coding background, it's like, let me get real. GitOps isn't that crazy of a revolutionary idea. It isn't. It's just exactly what we did with our application code. Write the code, check the code in, do a pull request, someone approves it, goes into a pipeline, run lots of security checks, away we go. We've been doing this for 20 plus years. Why it's new and exciting when we start doing it with infrastructure as code and providing loopbacks and think like why that's a big deal is a little bit like, maybe it is obvious. Anyway, back to our presentation. GitOps. Now that we know this is a tool in place to make this all happen, we can start with our layers. Here we go. And what are the layers? The layers are, this is delicious, by the way. Check that out. I made that. The cloud, the pipeline, the application's friends and dependencies, the image, the deployment, and this is where we're going to start talking about context, the runtime, which is our icing on the cake. Let's start at layer 0. This is the base. This is our buttery biscuit base. What are we talking about? Infrastructure as code, and therefore infrastructure as code scanners for what it is we create. Be that our CloudFormation, our Terraform. I got excited. And there's lots of free tools to do that. Check off for Bridge Crew. Kicks by Checkmarks. I just heard of that one recently. Terrascan by Acarix is one that I use. There are CSPM tools for once we have deployed, for making sure that what we just deployed is still in a declarative state. It is still what we said. No one's turned encryption off on S3 bucket. That's not happened. There are some examples where we can just detect, some where we can self-heal. It's all pretty cool. CSPM is a very growing industry. It stands for Cloud Security Posture Management. It's one of the Gartner things. So Gartner says it's a thing, right? We know that. There are some free tools for it. OpenCSPM is one, but there's lots of commercial ones out there. So I think this is a great place to start generally. Make sure the fundamentals of your cloud are correct before you start chucking applications into it. Why do we need to do it? Once again, when humans create code, you should treat it like application code. Understand that mistakes can be made and that there might be insecure defaults. So let's take a look and check that. Let's do a little hands-on right now. And I told you that I use Terrascan at the moment for that, so I'm going to just do that. So let's jump right in and have a quick visual of what we're doing. All right. So if you're like me and you download dodgy things off the internet, then you have this Terraform AWS WordPress template, which I'm sure is a disaster. Terrascan has multiple outputs. I'm just flagging that. Human JSON YAML. You should always have a machine consumable and an easily readable output. And to scan code with it, it's too easy. If anything, you just type scan, and I'm in the directory where my Terraform is, and presto, it spits out a bunch of the things I did wrong, or somebody else did wrong, and I was about to use recklessly. I find some easy stuff. So I find this on line 25. That's bad. I know that's bad. In fact, I'm even wondering why it's there. Like, this is a WordPress deployment. Why is it leaving port 22 wide open? So it was on line 25. That's on screen. And there we go. So it's just down there. I'm just going to delete this. I don't need this. Like, it seems kind of bonkers that that's even there, you know? All right, run again. And I see some warnings. I'm going to ignore those for now. Yeah, so I'm one less. So this is like, I'm not seeing anything that isn't easy to understand, right? So I'm not sure why I wouldn't do that. I would do that. That was easy. That was quick. And I get the low-hanging fruit of misconfiguration sorted so that I'm not putting something that is just dead easy into my configuration to start, into my actual cloud provisioning. Right. What are the pros of this? Now let's summarize. Infrastructure as code, controlled, observed, change workflow can be done using GitOps. It's chaos engineering friendly. I can check it in advance. Checking things in advance is always good. I didn't even add that there. I should add that. Reduction of dependence on tribal knowledge is all good. So I'm kind of summarizing overall at the moment. What are the cons of infrastructure as code? This could be controversial. Infrastructure as code from scratch will still be constructed with the same, let's say, haste as standard application code, which means it might end up just being an amalgamation of Stack Overflow, GitHub, cutting and pasting from your friends with potential insecure defaults like what just happened to me there. All I did there seriously was search AWS WordPress template for a Terraform. And I got that one. I didn't even check to see if it was out of date. I just used it. Another thing that can go wrong, and this was highlighted, I believe this was highlighted, if memory serves, in an article by Matt Fuller, who was one of the CloudSploit founders. the idea of template squatting. So the idea of if that became a very popular template, say that one I just downloaded, and everyone started using it from a similar repository, kind of like what's happening at the moment with images in Docker Hub, a popular image will have a squat, which will show up with a similar name. And you might download it by accident, and presto, you've got what you think is a reliable template, but actually it's tactically changed the trust boundaries to have something that can be more vulnerable. The last two are more operational. Infrastructure as code doesn't almost benefit from being as ephemeral, meaning we're not changing it based on feature requirements as often as you do application code. So it can age over time, and cloud requirements can change out from underneath the code we're using to provision, and there can be a security lack of synchronization there. So we need to be attentive to those things. All right, layer one. Layer one is interesting. This used to be a pretty boring part of this presentation, to be perfectly honest. Securing the pipeline. Supply chain integrity and provenance. And I'm talking about the internal supply chain. Why? And I debate whether I want to always call out a company like this one, SolarWinds. But it's not like, unless you're under a rock, you have heard of this. Getting access to the internal CI/CD pipeline is the keys to the kingdom. And if you can get in there somehow with some malware, and you are an egg, you are the hard outer but the soft inner of your development security and your software supply chain provenance, then you can do whatever you want, and you could control the build to produce what appears to be signed software that then goes out to your customers, and that's really bad. Now, what's the good news here? There are solutions available, and there's one there. I highly recommend checking out Intoto. It's written in Python. It kind of deploys anywhere. It does the job. And I'm not going to do a demo of it now because it's a bit obscure. Maybe if I had a longer time, I would do one. There are other tools out there, and it's great for preventing man-in-the-middle attacks and ensuring that the contents of everything as it is assembled from the moment it is submitted to Git is the thing you said it was. Your eggs, your flour, your vanilla extract, all of these bits that make your cake are still the bits that you originally got from the grocery store and put in the cupboard. There, committing to the analogy. The cons are that these kind of tools are difficult to deploy at scale. There's not a lot, if any, commercial solutions, but I'd love for somebody to comment and let me know. Layer two, securing the code, the actual code, like writing the source code, the code I used to write. Typically, when you're talking about scanning code like that, we call it now SAST, Static Application Security Testing. When I started into SAST, that wasn't a word. It was just called static. God, I'm blanking on what it was called, but it was just static analysis. Yes, thank you. And that was it. And it was mostly for quality because it was very popular for languages like C and C++ because it was just so easy to shoot your own foot off with those languages. And now it's for security. And you'll see on the slide I've highlighted IDE SAST as something separate. And I'm going to call that out because I think there needs to be more integration directly into the developer's IDE to really make this effective. And we're just not doing a good enough job right now. All right, why do we need it? Same thing as before. Humans are involved, which means we screw up. When I used to work in static analysis, we had a pretty reliable stat based on the open source offering of it that 1 in every 1,000 lines of code has some screw up, be that security or whatever. So that's still a pretty reliable number. And 1,000 lines maybe to some people sounds like a lot. It's not. It's so easy. You can do it in a day, and the thing you get wrong late at night could be a catastrophic error. Layer two, the pros. Many open source and commercial offerings are available. Now, I'd forgotten that I called out Coverity up there. Yes, Coverity. That's where I used to work. And Checkmarx is another great one. There's lots. I think some of the mainstays like the Vericodes and the Fortifys still all really good, right? And I think the real plus when it works is that there are huge cost benefits to finding bugs early. Shifting left and checking in the developer environment versus finding something in pen testing or support cases or a breach. any of that is good. It's so much better to do it that way. And one of the kind of unsung advantages of static analysis, I mean, I'm sure static analysis vendors will say this, but we don't recognize it as often as I think we should, is that it's one of the few things you can use to traverse all the paths of your code. Even if you do a static analysis on a larger piece of code and you do it out of band, offline, every now and then, that's a huge advantage because your testing, your pen test, everything you do, maybe if you're really good at TDD or something, then you catch every error case in odd, obscure path. But otherwise, it's very difficult. There's still huge advantages. What are the cons? A lot, actually. Slow and potentially disruptive. Lots of false positives. A con within a con is that those first two are known in the industry. So people have a tendency to be wary of static analysis tools out of the box, and that can limit deployment and get developer friction and resistance right away. The implementation is difficult sometimes, and particularly when we're talking about the latest and greatest in microservice, developers in each service team get to choose their own tech stack, typically, the right tool for the right job. And that's proving difficult. A one-size-fits-all static analysis solution is very hard to find because they are tailored to the language. To write a static analysis tool is like writing a compiler. It needs to understand the misuse cases of that language in order to be effective. And if you've got 17 different languages in your organization, it's really hard to do that. Few good open source solutions for the IDE are available. I'm going to call out ESLint because it exists. You can get it for VS Code, among other things. It's pretty good. And then I realized my big fat head's in the way. So let me just get rid of my skull there. Limited reach in next-gen languages. For Golang, you've got GoSec, which is pretty cool. I use that. Rust, you've got Clippy, but when you start getting into these new areas, you tend to limit what you can find for open source. So based on that, let's take a look at an example of what we can do for free. Now, this is guardrails. I don't know if you've heard of guardrails. Move fast, be safe, sounds good. You log into guardrails, and you do that with your GitHub, essentially, which is what I've done. And then presto, all your repos just show up visible, and you're thinking, all right, very cool. And I like to collect. Some of these I work on, some of them I just have them for demonstrations like this. A good example of that you can see here is Juice Shop, which is OWASP's intentionally vulnerable node application. And so I should find vulnerabilities with static analysis in here. And sure enough, I look at the master, 6 vulnerabilities. I ran a scan and I can take a look and presto, bad things, hard-coded secrets, insecure use of SQL queries leading to SQL injection, good old-fashioned OWASP top 10 classics here. And that's great. Now this is a SaaS solution. You can see it's like guardrails.io. It's got integrations with Jira if I want. This was free. Can you believe that? There is a paid version that gives you far greater scale. The insights, for example, is something that's there. But what blows my mind is, look at the language coverage. Now, some of these languages are amazing. Kubernetes and Terraform are not two of those things that are amazing. They are very lightweight. But the Pythons and the Go's and some of those are implementing already those tools I was just telling you about, those newer tools. So it's quite cool what you can get for free as a SaaS solution, if you like that sort of thing, just out of the box. It kind of blew my mind. All right, let's move on to layer 3. Securing the open source supply chain. And this is often confused when I was talking about layer 1, the supply chain, the internal supply chain. Layer 3 is the things from outside coming in. Typically in the industry, that's called SCA, software composition analysis, or typically lazily dependency checkers. Free and open source software would include OWASP's dependency checker. NPM, there used to be a separate tool for that, and now it's integrated directly into NPM, which is awesome. I don't know if anybody ever uses it or looks at it, but it is there embedded within the results that you see. There's tons of commercial solutions out there. Black Duck and Sonatype are two I'm familiar with, but many others are available. This is not an endorsement of any of the commercial solutions. Why do we need this? Well, this used to play second fiddle to SAST back in the monolith days, but now it's kind of taken the lead, because if you look at various reports by any of the larger entities that I've listed above, 80% of our software consists of open source dependencies. And I think we kind of deep down, we know that. And if the open source dependencies and the versions of those open source have known vulnerabilities, they are known not just to us, but to the bad guys. And there are tons of scripts and bots and everything out there, weaponized and ready to go, waiting for us to trip up and use a version that has something that can be leveraged. It's bad. So we should just do the easy work and check for it. What is the downside? Well, they can be difficult to prioritize. Let's talk about the pros, which I realize I just said ahead of the slide. Finding known vulnerabilities is a definite thing. It's low-hanging fruit. You've got to do it. But unfortunately, there can be instances where there is bloated images. There can be bloated package manager usage. I'll give the example. So I'm writing a Node application, and throughout the creation of that, I'm bringing in all sorts of dependencies and packages that I think I need during development. But in the end, I decide to replace it or remove it or find a different method. But I don't necessarily always remove that. And then there's dependencies on dependencies. So I say I want to use this package, and it turns out that I need 5 other dependencies to run that one. I heard a really good podcast where the maintainer of the NPM repository said that there are about 5, like there's how many packages in there, right? And he said 500 packages are pulled directly, 2,500 are pulled indirectly. So there's a core of about 500 being used, but as a result of using those, they need another 2,000 on top of that. So knowing the vulnerabilities in there, this is a complicated process, and this is why SCA is really useful. Only if you only pull the things you need. It can be very difficult. If you consider that there's 15,000 vulnerabilities disclosed per year, and that's a low number, that's because I'm factoring in averages from earlier years when I got that number. It can be hard work to sift through the mess. All right, moving on to layer 4, securing the image. Finding known vulnerabilities in base image and dependencies by scanning images. This is totally critical. It's a little like SCA, and I'll mention that overlap a little bit. We can also check for Dockerfile best practices. So not only are we scanning the image and the contents for vulnerabilities, we're checking to make sure that we just haven't done something a little bit like our Terraform check that is just going to be insecure by default. An example of that would be leaving the default user, which would be root. That would be bad. And if you think of the RunC vulnerability in January 2019 that enabled, if you allow containers to run as root, a malicious container could essentially result in remote code execution on the host, taking over RunC. And I used to do a demo where I used that as an opportunity to create a reverse shell out, and then I had root host access, right? Really bad. And also some slightly more inconsequential ones, but still important, like using add instead of copy, things that we should make developers of these images, designers of these image files aware of. Well, as we know, the defaults can be dangerously insecure. User images can introduce or do introduce user space operating system dependencies now that conceal those dependencies from traditional scanners and can have critical vulnerabilities. So the pros. Finding CVEs is easy with image scanning. Images are typically smaller and so far, so scanning them is quicker, and typically they easily integrate into CI pipelines or even into the developer desktop. They teach best practice often enough. They do often include some SCA. So if there's a visible package manager in the image, a lot of the more commercial ones, I don't think of a lot of the free ones do this, but certainly the commercial ones do. They check that and they use that to provide a kind of, well, an SCA essentially check. So there's a bit of overlap. Plenty of open source tools, though, just to get started, are available. What are the cons? Controversial. Image scanning has become a thing. Security teams are aware that images conceal vulnerabilities because of that operating system, the user OS comment I made earlier. And they've now realized, oh, we can't just scan the destination. We have to scan the image itself, and we have to get those vulnerabilities, and we got to put those into our vulnerability management system. And that is like that's doing a whole, well, that's a necessary evil, but it's doing a whole lot of nothing if you don't have a plan on what you're going to do with those vulnerabilities or a way to prioritize the result. Very confusing. But how hard is it to get started with this stuff? Not hard at all. So we take a quick look at an example that I'm most familiar with. I mentioned a few, but trivia is one that I just kind of know inside out because I use it regularly. You can use it to scan lots of things, image, file system, repos. You can do it I like that you can do it quietly. You can embed this in the CI, and it's as easy as running trivia image. And let's pick Alpine because everybody's generally familiar with Alpine 3.13 is the latest. And it's pretty quick. It maintains its own local database in Git, so it syncs itself up with the deltas. And there are, okay, at the time of running this, some new vulnerabilities I didn't think were going to be there. I thought this was going to be a clean slate. There are fixed versions available. So this is actually really good information. There's no newer version of Alpine, but I could fix this myself. That was pretty cool. What if I run something a little bit more popular, but something I know will be a little bit more bloated? And I got the syntax wrong. And it's warning me not to use latest. You shouldn't do that with these tools because it's non-specific, but that tar one. But there's a lot of vulnerabilities here. Too much for me to digest. So I'm going to pipe that into head because I know the summary's at the beginning. Something I actually don't like about trivia is that I can't just get the summary out of it easily. And I have to use this. Yeah, you can see. So I can see I have one critical. And this is almost like a pro and a con. You saw the pros of checking Debian operating system, checking Alpine, and that was actionable information. Some of the more complicated examples like this, if I filter on just that critical vulnerability, is that you don't always end up with something as a developer and not a security professional that I can use. So here we go. You can see I've got a 2019 vulnerability. It's a little old. It's an out of bounds read during comparison. I don't know what the downside is. There's no fixed version. Do I care? I can run over to Shodan if I'm really keen, which most people aren't. And I can see that there are no exploits for it. Okay, cool. I don't know. I don't know what to do now. So that's kind of a visual con to do with that one. So as much as it's awesome to have desktop access to the to be able to make changes and early as possible to vulnerabilities you find, that's really great, right? But the problem with that is that the more complicated you get, the more you've got to defer to the security team. Because as like a point of reference, if it's an old vulnerability, there's no fix available. That's the feedback you get. Even though it's critical, you might just have to let that one go into the system, into CI, if there's no alternative, and see what the security team does about it to sign off that risk and maybe whitelist that vulnerability. But it can be confusing. So I'm just letting the world know that it's not always straightforward. It's when you see things like that as well, it would be great if you could just at least find out, well, where's this vulnerability in this image going to be running? Nginx being a bad example because that's probably running front and center, right? All right. So what have we seen so far? We've seen some pretty cool things in terms of scanning our infrastructure as code for provisioning our cloud environment. We're hopefully maybe learning about a little bit more about how to secure our supply chain. And we already knew about static analysis. That's difficult, but hopefully we see that there's more value in SCA, and maybe even image scanning can do a bit of both for us cheaply and easily and early enough for us, which is cool. So what we're going to do now, we've got these multiple opportunities to create awareness of vulnerabilities and misconfigurations, and we're going to go and we're going to get ourselves, let's all go to the lobby. I wonder how many people remember when this was actually a thing. And get some risk context is what I'm calling this. And that starts at layer 5. Layer 5, securing the deployment. Now, this is probably the most underused part of this presentation, and I'd love to see us get together and develop things in this space. At the moment, it's mostly best practices for Kubernetes objects, checking out YAML files or checking Helm, looking for operational risk and looking for security risk. Why do we want to do this? Well, there's multiple reasons. The defaults, much like Docker files, can be dangerously insecure. but also we can bring essential context to image deployments and vulnerability management. And I'm going to talk a little bit more about that in a moment, but I will step forward and talk about, there are many open source tools available for this. KubeLinter is a great one. That's a StackWorks one where I work. KubeScore exists as well. Some of the Terraform ones also do this, like Checkov, Kix, and KubeScan. Sometimes they're not as good as the dedicated tools. I quite like KubeLinter, and I think off the back of that, we're going to take a quick look at how that works. And it's easy. By the way, a lot of these tools that I'm showing you, they install on a Mac OS, which is brew install. So you can do brew install KubeLinter, no excuses. Certainly not a complicated help. If I look at checks, which I do like, I can see that these are all the things that it's going to look for. And there's a enabled by default I'm going to show you. So you can see like CPU requirements, run does not root. That seems good. Requiring a label by the owner. Well, that's being a bit pedantic, but that's off by default. So there are some interesting ones that are no-brainers you want in there, and some other ones that we have as options by default, but trying not to be too noisy. So scanning is as easy as lint, and I've got email service rushed. That's from Hipster Shop. You can go to use that for experimenting. But you can see that I've got memory, CPU not set. I've got security context. So there's some help here. So if I don't know what that means, security context, I can paste that in and I can take a look and learn, okay, defining security context, there it is. Allow privilege escalation false. That seems good. All right, so I'm probably missing that whole section. And what's interesting is that if you generate YAML using kubectl, which I did, like if you're doing the CKA test, you learn to do that. It doesn't produce the best defaults. So I've fixed this, you can see, but the differences are there. Security context I added and resources I added. That's not a complicated fix. And what's interesting about what got fixed is that, and I said this, I'll repeat myself. If you do a kubectl create deployment with a name and you generate the code, the baseline code for your deployment just to get a head start, say you're not just going to download it off the internet, you're generating something to start. Security context isn't there. Neither are the CPU or memory requirements. Like some of the things that from a security perspective are essential, there's no placeholder for it because they don't really know what to put there because it's up to you, right? There's no ability to create that space or placeholder. So it's interesting that it's very easily forgotten. All right, so that aside, securing the deployment. This is a caveat to layer 5. And I mentioned this a little bit earlier. I think I actually did call out CDKs there. There is this new tendency, and this existed previously in code in the world of where things like TypeScript, and this is TypeScript again, actually, that can be used to generate JavaScript that runs in the browser. There used to be a security issue with static analysis there because if you scan the code that was going to run in the browser to look for insecure JavaScript, how did you translate that back to the abstraction layer? Because it was very difficult to fix security issues, and there's all this mapping that had to be done. The same thing's happening again here. If you look at this side, the TypeScript, and it maps and generates this YAML, and I can see that I'm kind of in the way. So let's get rid of my big fat head. There is a mapping. So if I scan the generated YAML, and I need to go back and see how that mapped back to my abstraction layer, I can have a security problem. So I just wanted to let you know that that can accelerate time, but it can create a problem in terms of what we do about it, right? The actionability. Okay, so what are the pros? Many open source tools exist. The cons, big con, few if any open source tools combine image vulnerabilities with the deployment context. Wouldn't it be great if KubeLinter ran Triby? The images are there. They're all listed. I know where I'm going to pull them from. So wonder if I can go take a look, particularly if they're public images, obviously, right? If I have accessibility to make that happen, it would be cool if we did that, because then I can answer some key questions about this. I've got these vulnerabilities, be that in my registry, my packages, or whatever. What if I knew where it was going to be deployed? What if I knew the criticality of the app based on metadata? What if I can see that this is privileged? Suddenly, vulnerabilities take on new priorities? What if it has access to secrets? What if it has internet reachability through exposed ports? What if it has a complicated baseline because of a complicated base image? Kind of really changes the game, doesn't it? I would be able to prioritize a container with a CVSS 9.8, and if it's in a backend service, like it's got no internet connectivity, it's not running as privileged, it has a very simple recordable baseline of process activity, all of this is actually good because that's relatively safe. Say, for example, like that one we found in Nginx, although Nginx is maybe not the best example here. It could be an internal Nginx. Let's just say that. Against a container that's running with a CVE that's 7.6 or about to run, in multiple replicated front-end services used in several applications, behind load balancers, exposed ports, complex base images and behaviors, which often lead to tools present for attackers like curl, wget, and nmap. Really bad. Even though it's a lower score, I would prioritize this higher. So this is what we're trying to get to when we're talking about the value of context and what we can do to try and utilize context to prioritize the seemingly never-ending vulnerability management nightmare that we have to contend with. All right, let's get to the end. Layer 6, the runtime. Maintaining the state of security. What are we doing around here? Well, there's actually a lot of interesting things that are developing in this space. This is the icing on the cake, though, remember. If we've done everything we can do leading up to this, we have done everything we can to make sure misconfigurations were eliminated in all forms of code. We've scanned for vulnerabilities and dependencies and did what we can to replace and upgrade and make sure we're using the latest and greatest when necessary to ensure that we're deploying the least number of vulnerabilities into runtime. Ideally, at layer 5, we are ensuring that we are prioritizing properly based on context. Then when we run, we're not necessarily chucking it and seeing. We're not putting a magnifying glass on what's running and just hoping for the best. And we have exciting new tools to watch things in runtime. eBPF is pretty much becoming almost like a foundation for what we do to find things in runtime these days within a containerized and cloud-native environment. Tools like Falco from Sysdig, Tracy from Aqua, Cilium from Isovalent, which is super cool, Calico from Giguere, all of these things are implementing tools in runtime. Looking for anomalies, presenting them as Kubernetes objects, preventing using admission controllers if we can check state in advance. And then, of course, there is security as code that is being introduced and gaining popularity like OPA. So this is all really good. These are all new methods that we should be looking at if we're focusing on layer 6. Why? Well, even if we do everything in 0 to 5, there's only so much we can do, right? 0 to exploits and new misconfigurations we don't understand will exist, and we need to have something in place to catch that up. INFOSEC people, well, why do we do it? I say because INFOSEC people understand the language of layer 6. They do. And you can gain enthusiasm for what it can do there. 0-day anomaly detection will always be required, and it's an absolutely important safety net. But that's what's important. It should be a safety net. It shouldn't be the single point of security. That's both expensive, again, the costs, reactionary, labor intensive, and can often be a scenario where if we are simply applying monitoring, the horse is bolted, now we're closing the door. So anything we can do to be proactive is absolutely essential if we can, but it's still required. Make no mistake. So what are my key takeaways? Open source is awesome. Free stuff, great place to start. If you've got constraints in budget and you're making decisions around your security posture across your entire development pipeline, just go out there and find the open source tools that can get you a head start, that can bring the awareness. Sure, maybe they won't scale, but you're going to have a great idea of where your gaps lie. Shifting left, a phrase commonly used by security enthusiasts, and people in DevOps are like, what are you talking about? It sounds like you're just going to give me all the pain. It is kind of like that. It's hard work to shift left. The more people you involve in any project, the harder it becomes. I think we kind of know that in life. So if it's not super easy, your shift left efforts probably won't work. What we really want to do is shift middle, or everything, or everywhere. Simpler things easily implemented throughout the entire pipeline mean a lot of different stages. So it's a lot more valuable to make sure everybody does their small part than a lot of people do a big part at any phase. I'm not sure I said that correctly, but I think it sounds good. You get the idea. Context can be a huge advantage, and I alluded to that, and I think this is something that the security world is moving more towards. The more you understand what is happening in your Kubernetes environment, when we start to merge our knowledge of security with our knowledge of observability, we are going to have a very powerful result in terms of really reducing the probability of some kind of security problem. Everything is code. EAC, let's call it that. Plus GitOps, plus Kubernetes, reducing our imperative intervention, creating more security challenges on the way, different security challenges, but certainly not insurmountable, means a declarative, deterministic, and far less probabilistic result. And that's where we need to go. So thank you for watching Deterministic Security through Kubernetes, or Layer Cake. Look at that delicious thing. I made that. Definitely happened. Thanks for watching. My name is Steve Giguere. Here's all my details again if you want to get in touch and look me up in any possible way. I appreciate that. That is the end. Steve out. I just got to figure out how to stop this.